And then now we will focus on calculating the acceleration. Re shumisha a Newton's second law formula that says F net e lekana le ma. The best way to explain this is by using the example. Re ke shumishe a very simple example. It says a force of 100 newtons is applied to an object of mass 10 kilograms. There is a frictional force of 25 newtons that acts between the surface and the object. Determine the acceleration of the object. More le an object is being pulled horizontally. More le a force applied. This object is in this direction based on Newton's second law. Newton's second law actually or apply a force on an object. That object is to accelerate in the same direction of the applied force. But it really makes sense. O push an object, we push her to the right. This object is to the right. So now our level this question already rabia. First, I draw a free body diagram. Arnali a gravitational force that is acting downwards on the object. And then arnali a normal force. Right, about a normal force always act perpendicular to the surface. This is our surface. The normal force it over in this way to create 90 degrees. And then arnali force applied in this direction. And then rabali a frictional force, because frictional force always act opposite to the direction of motion. So now let's write the formula. The formula says F net elegana le ma. And then now we're going to calculate acceleration. This one give mass and then ranalona, which is 10 kilograms. And then this is F net. Let's understand already what is F net. The weight net in physics in total. So F net in the total forces. But based on Newton's second law, F net the vector sum of all forces acting parallel to the direction of motion. Object yarena act in this direction to the right. Ronyaka only the forces still the parallel to the direction of motion. Object yarena yagodim. Ronyaka only the forces still the act parallel to this direction of motion. For this object, arnale force applied, arnale frictional force, arnal force of gravity, and then arnale normal force. But level the direction of motion first. This object here to the right. Only the forces still already parallel to this direction of motion. Arnale force applied, yellow ray is also to the right, and then rabale frictional force, yellow is to the left. But these forces the parallel to the direction of motion. But a normal force and the gravitational force, these forces they are not parallel to the direction of motion, because our object is going to the right and the normal force is vertical. So they are not parallel, because what we know parallel lines never meet. So for this problem, our F net will focus on FA and frictional force. Another thing that is very important, our object is going to the right. The force is still the actor to the right, the over positive, and then the force is still the actor opposite, over negative. Here, our object here to the right, and then this force applied is to the right. Error this force applied you were positive, and then this frictional force error you were negative. Re onalen object is going upwards, and then only the forces in this case. Re object erna ya upwards. Error the forces they are up, you were positive, and then they are downwards, you were negative. So now for this problem, force applied it will be positive, and then the frictional force it will be negative. So now we can substitute. Renally force applied, which is 100 newtons, and then renally frictional force, which is 25 newtons, and then our mass is 10 kilograms, and then renyaga acceleration. So from there 100 minus 25 is 75, and then from there our divide both sides got 10. So our acceleration it will be 75 divided by 10, and then it will 7.5 meters per square seconds. But acceleration is a vector quantity in another direction, east. So this is our answer. The reason our east is because this object here to the right, and then to the right is positive, and then leave this object really acceleration here positive. This acceleration is really negative, to the left. This object it was decelerating, meaning a way decrease the velocity. So this is our answer anyway. The next problem. This one is a force of 100 newtons pulls an object of mass 10 kilograms to the right at an angle of 60 degrees above the horizontal. The coefficient of kinetic friction between the box and the surface is 0.1. Determine the acceleration of the object. This object now is being pulled at an angle. The moment this object is pulled at an angle, this force you create the components. Because this object is up, a vertical component is up, and then a horizontal component is acting in the x direction. So what we know to calculate the acceleration, Rishmisha F net elegana le MA Ronyaga the vector sum of all forces still the actor parallel to the direction of motion. Object erna here to the right. Arela Ronyaga only the forces still parallel to this motion. But first draw a free body diagram. Arnali a gravity which is downwards, and then arnali a normal force which is perpendicular to the surface. Arnali a friction which is the kinetic friction. The moment of the coefficient of kinetic friction only a frictional force. So you are in the opposite direction because this object here to the right, and then our force applied is in this direction. But now because arnale components, arnale a horizontal component, and then this horizontal component here to the right is parallel to the direction of motion. So arnale a horizontal component here. And while we draw a free body diagram, we do not include the components because more normally a force, but I include because that components the this force applied. But when I can draw for the sake of for calculate this acceleration, more normally a horizontal force. e re la gore ge re nyaka yo calculator this acceleration for the f net ro substitute ka f horizontal and then ra substitute ka frictional force. But lemoga gore ga re ne friction and then ga re ne horizontal. Re la gore first re tlo tshwanela gore re kreye this horizontal and then re kreye this friction. So re find this horizontal first. Re tlo shumisha a trig ratio because ka kgona bona gore mo re na le angle and then mo re na le a hypotenuse. So re la gore calculating the horizontal component re tlo re cos theta e lekana le adjacent ke horizontal and then hypotenuse ke 100 newtons. From there re la gore fh e lekana le cos 60 and then times 100, so re fa gore ke 50 newtons. And then now re tlo tshwanela gore re kreye a friction. But ge o ka gopola for the previous videos ge be re calculate friction re be re dira in this way. Re tlo re friction e lekana le coefficient of friction and then times normal force. But ga re ne normal force for this problem, so re la gore re tlo tshwanela gore re kreye normal force first. What we know gore re na le a normal force which is upwards, and then re tseba gore gravity is downwards. So for the fact gore this object is not going up or down, re la gore the upward forces and the downward forces are balanced. So re la gore I can say Fn plus Fv e lekana le mg, which is our gravity. So re la gore Fn e lekana le mg minus Fv. So Fv re tlo kreye by using the trig ratio. Re la gore this is sin theta e lekana le opposite, which is Fv, and then divide by hypotenuse, which is 100. So re la gore Fv e lekana le sin 60 and then times 100. So from there ke tlo substitute here. Mass ke 10 kilograms and then gravity ke 9.8 and then ke tlo re minus sin 60 and then times 100. So e re fa gore ke, so this is our normal force. So from there, because re na le normal force, re la gore ka kgona calculate the kinetic friction. So re la gore re tlo re 0.1 and then times 11.40 and then re fa gore ke 1.14 newton. So now re na le friction. So based on this F net, re tseba gore re nyaka the forces that are parallel to the direction of motion. Mo re na le friction. So re la gore re tlo re because horizontally rena ia in this direction, re la gore is positive, and then because friction is in the opposite direction, re la gore yo ba negative. So re la gore mo ke tlo re F horizontal minus friction equals to MA, and then F horizontal re krile gore ke 50 newtons. So re tlo re 50 minus 1.14 e lekana le the mass is 10 and then re nyaka acceleration. So from there ge o ka re 50 minus 1.14 e tlo fa gore ke 48.86 e lekana le 10a, and then from there ro divide both sides ka 10. So re la gore acceleration e rena e lekana le 4.89 meters per square seconds east. So this is our answer. Ka kgona bona gore what is important, o tlo tshwanela gore o identify the forces tse le gore o di shomisha for F net. So ka lemoga gore this force is parallel to the direction, and then also this force is parallel to the direction. But free body diagram dira gore dilo di kgone ba very easy. So that's it for this problem anyway. This one here, a force of 100 newtons pushes an object of mass 10 kilograms to the right at an angle of 60 degrees to the horizontal. The coefficient of kinetic friction between the box and the surface is 0.1. Determine the acceleration of the object. More nearly a similar problem, but just that now this object is being pushed. Here the previous one, it was being pulled. So that's the only difference. But first, I draw here a free body diagram. Ranally, a gravitational force, which is always downwards. And then ranally a normal force, which is perpendicular to the surface. Because this is the surface, I rely a normal force, it's going to create 90 degrees. So this is 90 degrees. And then ranally a frictional force. For the reason you are feeling the coefficient of kinetic friction, ordinarily a frictional force. And this object here to the right, our friction it over to the left. So ordinarily a friction in this case. And then this object is being pushed downwards. This is the force applied. And then now let's see, because this object is being pushed downward at an angle, you create a component here vertical that is also downwards. So more normally a vertical component downward, because this force is going downwards. So that is why FV is your AFS. And then normally a horizontal component here, because this object here to the right, FH it to the right. So now let's see. Fnet illeganally MA. That's why this Fnet only the forces still already parallel to the direction of motion. This object here to the right, so ranally friction yellow is parallel to this direction of motion, here opposite direction, and then ranally a horizontal force yellow here to the right. So actually for the net force rashumisha F horizontal and then rashumisha the kinetic friction. But because this one here to the right, here horizontal, here positive, and then here friction, because it's in the opposite direction, here negative. From there, I can say FH and then minus a friction, MA. So first, find the horizontal, just like for the previous one. Relay cos theta adjacent over hypotenuse. Adjacent yarnagi FH and then hypotenuse 100 newtons. From there FH cos 60 degrees and then times 100. So if I 50 newtons. And then now we find the friction. That's why friction the coefficient of friction and then times the normal force. But normal force, so first find the normal force. But this is the normal force and then this is the gravity. So for the reason here this object or fasi, the upward forces delicanally the downward forces. And then now for downward forces FG and FV. So Fn, which is the upward force, e lekana le the downward force, which is Fg, and then plus our Fv. Remember our Fg e lekana le mg. And then from there re tlo tshwana ko re find the Fv. So re tseba gore Fv re tlo shumisha a trig ratio, re la gore re tlo re sin theta e lekana le opposite over hypotenuse. This is Fv and then over hypotenuse. From there re la gore Fv e lekana le sin 60 degrees and then times 100. So from there re ka substitute. Ke na le mass wa 10 kilograms and then the gravity is 9.8 and then plus sin 60 degrees and then times 100. Re fa gore ke 184.60 newtons. So this is the normal force. Re la gore now re ka kgona go calculate the friction. So now let's calculate the friction. Re na le 0.1 and then times the normal force, re kry-ile gore ke 184.60. So from there e re fa gore ke 18.46 newtons. So now re ka kgona go calculate acceleration. Re na le Fh re kry-ile gore ke 50 newtons and then minus 18.46 e lekana le ma, but mass re na le ona ke 10 kilograms and then times acceleration. 50 minus 18.46 e re fa gore ke 31.54 and then e lekana le 10a. And then now because re nyaka acceleration re la gore re tlo divide both sides ka 10. So re la gore our acceleration e re fa gore ke 3.15 meters per square seconds east. So this is our answer. O ka lemoga gore this problem actually tshwana le ya the previous one. The only difference in over ge re find the normal force. So that's it for this problem.